Now example 2.4. Four charges are arranged at the corners of a square ABCD of side D as shown in the figure. Find the work required to put together this arrangement. B. A charge Q0 is brought to the center E of a square, the four charges being held fixed at its corners. How much extra work is needed to do this? Now, in this particular example, we have to apply the concept which we discussed in the previous theory. First of all, we have to place one charge at one point and we have to calculate the work done. Then after we will bring second charge at second point, then third charge, then fourth charge, and in this entire process we will calculate the total work done. Now see here, first we bring charge plus Q from infinity to point A. Then work done will be 0. Because here work is done against the field, but there is no field. Initially there is no field. Okay, there is no potential at that particular point. It implies that the work needed to bring charge plus Q at A W1, that is equal to 0. Now bring charge minus Q at B. So work needed to bring charge minus Q at B. So minus Q into potential at B, but at present only one charge is there at point A. So potential at B, that will be of A. So potential of A at B, that is KQ upon R as per that equation, that is KQ by D, and multiply it by minus Q. So work done, that is minus KQ square upon D. Clear up to this one?
Yes, sir.
Very good.
સર
બોલો.
સર તમે જ્યારે બોલતા હતા ને ત્યારે રેકોર્ડ નતું થતું, હવે રેકોર્ડ થાય છે.
હા સર.
Now work needed to bring charge plus Q at C. So that is W3 equal to plus Q into potential at C. Now potential at C, that will be due to two charges. One charge that is at A and another charge that is at B. So we can write Q into potential of A at C. So that is KQ upon root 2D, as well as potential of B at C, but at B the charge is minus Q. So potential, that is minus KQ by D. It implies that the resultant work need to bring charge plus Q at C, that is W3 equal to KQ square upon root 2D minus KQ square by D. Clear? Now next one. Work needed to bring charge minus Q at D. So that is W4 equal to minus Q into the total potential at D, and total potential at D, that is potential due to charge at A plus at B plus at C. Okay. So minus Q into, now potential due to charge plus Q at A at D, that is KQ by D. Then potential due to minus Q, which one is at B, that is minus KQ upon root 2D. Then after potential due to plus Q, which one is at C, that is KQ by D. Now take this minus Q inside the bracket. So W4, that is minus KQ square by D plus KQ square by root 2D minus KQ square by D. So that is equal to 2KQ square by D plus KQ square by root D, root 2D. Clear? Now here we calculated the work done to bring different charges at the corner of the square. So total work done to assemble this particular system of 4 charges, that is W1 plus W2 plus W3 plus W4. So W1, that is 0. W2, that is minus KQ square by D. Then W3, that is KQ square by root 2D minus KQ square by D. And work W4, that is minus 2KQ square by D plus KQ square by root 2D. So resultantly you will get minus 4KQ square by D. जो minus KQ square by D एक वखत, आ बीजी वखत અને અહીંયા બીજું બે વખત. So total minus 4KQ square by D. And KQ square by root 2D, that is 2 times. So that is 2KQ square by root 2D. If we take minus KQ square by D common, then into bracket 4 minus root 2. This is the total work done to assemble a system of plus Q minus Q plus Q minus Q charges at the corners of the square. Clear? Now this total work done will be stored in the system in the form of potential energy. So in other words, we can say this minus KQ square by D into 4 minus root 2, that is the potential energy of this particular system of 4 charges. Now, in second question, we want to calculate the total work done to place charge Q0 at the center of the square. So first of all, calculate the potential at the center. So potential at the center of the square. So center of the square, that is at the same distance from each corner, and suppose that distance is R. So we can write the potential at the center, that is equal to KQ by R. This one is due to charge at A. Then minus KQ by R, that is due to charge at B. Then again plus KQ by R, that is due to charge at C. And again minus KQ by R, that is due to charge at D. So resultant potential, that will come to 0. Now, extra work needed to bring the charge Q0 from infinity to that particular point, means at the center. So that work done, that is Q0 into potential at the center. but potential at the center that we calculate, it is 0. So work done, that is 0. Clear to all of you?